Hello, happy to be here. It's actually, pretty much a continuation of the prior talk, so I'm happy to pick up because Sebastian already sold you on confidential computing, so I can skip this part, I guess. So just briefly, pretty much what he introduced. There's use cases for confidential computing. That some workloads require, just think of GDPR, PII data processing in Europe, and confidential computing is a technology that kind of unlocks this also on cloud providers. This is why CSPs have an interest into enabling customers. The question why confidential containers in particular are interesting is pretty much because we aim to democratize the use of confidential computing, so it's not trivial to set it up and to run it in small to medium businesses. Cloud Native is actually a quite good match for this, because Cloud Native is these days a bit of a platform of standards, how modern applications are built on the cloud. So we have some assumptions that we can build on, we have some abstractions that we can build on, and the rationale behind is that pretty much the building on top of those abstractions will also help with the adoption of confidential computing in general. And we also learned in the prior talk about confidential virtual machines. Maybe this is a bit of an opinion, but from my perspective, the virtual machine approach is a bit of an iteration of the earlier process-based enclaves, namely Intel SGX, that required customization to the application and were tricky. If you had an existing workload and you had to put it in the enclave, there had to be modifications, which is sometimes not trivial to do, as we heard, for example, in the Postgres case. Virtualization, I think, is a proven technology. It even works like in hostile multi-tenancy environments. So that's why public clouds can use it. And the premise that is pretty much always cited is you are able to lift and shift existing applications into a VM, in this case a confidential virtual machine. So I wouldn't say you don't have to touch it at all, because there are certain assumptions that you have to make about your software if you want to run it in those CVMs, but in general I think this still holds. And there's several examples of those confidential virtual machines. It's MED EV, Intel TDX, the ARM model, and IBM Secure Execution, which is a bit different than the prior ones, but in essence they're like isolation technologies that have been extended with confidentiality guarantees. So, and this means in particular that you have discrete trust domains, so there's a different level of trust on the host of the CVM and the guest. So this is quite interesting because this turns some models around. So the CVM guest is in this case really almost a tenant, and the CVM host, so the VM that you start on a CSP, would be not something that you completely own, but that you assume that is essentially in the trust domain of the infrastructure provider. And in this case, the CVM host is really deprivileged, like we've seen before, and it's not able to access or tamper with the guest memory or CPU state. So it's not just the memory, it's actually also the CPU register. So there have been several iterations of SEV, for example, where they started with just memory, then CPU registers, and later added more and more facilities to harden this. So it's at this point, I think, somewhat mature. And if you talk about Cloud Native, I think it makes sense to quickly talk about Kubernetes, because it's more or less almost dominant model for those applications. So in Kubernetes, there's a cluster. It has a control plane. We have several nodes in those clusters. And Kubernetes has a notion of a pod, which is like co-located containers that share certain namespaces, and they constitute like a logical unit of computation. So you would group several containers into pods if they really need to run together. So this just very briefly the model of Kubernetes. And we need to kind of marry this with the notion of CVMs. Yeah. So before we've seen like there were no VMs in place. There was pretty much a node and the pods in between. And in this case, we have to reconcile both ideas. And there's approaches for it. I think the straightforward one is to think like just consider Kubernetes as a whole as an application that you want to put into an enclave. You kind of bootstrap trust between individual nodes, but all in all, it's a logical, confidential application. So this is in a way straightforward, and there are products like Edgeless has a Constellation product that does this. The downside is people tend not to run their own Kubernetes. They want to use like hosted solutions, so the control plane is operated by a CSP, and in this model this is not possible. And also Kubernetes is a huge application, and as we learned before, in your TE you want to have small software that you kind of trust, and Kubernetes is just a rather large application in your TCB. There's an alternative model that you also can do today. It means like just take CVMs, make them nodes in Kubernetes. This looks like a neat solution, but it has drawbacks because parts of the control plane in Kubernetes are also running on the node. So if you have a CVM, you need to run a kubelet in there. You might probably require daemon sets. So like processes that are privileged on your node that you don't own. There's a bit of serverless, I would call it, model where you say, okay, then in this case, let the CSP do cover the management of the containers, and I'm just deploying groups of containers. So this doesn't use Kubernetes or specifically the Kubernetes abstractions, and this, I would say, also the downside here, because in this model you don't have the integrations with Kubernetes or the ecosystem. You're missing out. And finally, there's the model that the Confidential Containers project is using. That means we deploy Kubernetes pods in CVM. So those units that I mentioned before, they are considered as a confidential boundary that makes sense. Yeah, and this is the open source project, so it's a CNCF sandbox project at the moment. And it implements this idea of confidential pods. And this is quite a collaborative multi-vendor effort, so there's, I know, Intel, AMD, some RISC-V companies, cloud vendors, Alibaba, Azure, Red Hat, and smaller security-focused companies are in there. The project is mostly written in Rust and Golang on the close to Kubernetes components. And the idea is to pretty much cover the project or the components of this, and while walking through the individual components, we get an idea what the project wants to achieve and what is possible today. So let's start with Kata containers first, and an operator. So Kata containers itself is itself not part of Coco. It's an adjacent project, but it's very attractive because it actually does what we need already. It is quite a mature solution that focused on isolating containers in very lightweight virtual machines. Yeah, it has certain nice properties. It supports different solutions for running VMs like QEMU, Cloud Hypervisor. And from the Coco side, those components for Kata are put on the nodes using the Coco operator. And so here we see briefly the architecture of how Kata looks with containerd. So there's a lot of Kubernetisms in there, but I think we can focus on the right side of the picture. So we see those red components. It's the containerd Kata runtime that's responsible for spawning those VMs. And on the right side, we see the Kata agent, the guest kernel, and the pod sandbox. And this is the part that's running in the virtual machine that's isolated. And in the Kata deployment, Kata is doing a lot of facilitation in terms of adding resources to the guest. Like it passes through devices, it shares volumes, it provides it with container images. But in our case, this is quite a problem because the left side is untrusted and the right side is trusted. So we can't really take Kata verbatim and make it work in confidential environments. We have to do some adjustments. There's also some problems with Kata on the cloud because Kata implies that you require bare metal nodes or nested virtualization on those cloud VMs, and sometimes with confidential technologies that's not even possible. And it has some performance and complexity costs if you have 2 layers of virtualization. So what we can do today to kind of circumvent this is there's a Kata implementation of a remote hypervisor, which instead of creating a VM locally, it spawns pretty much a peer VM next to the node and facilitates all this instead of to the VM locally to this peer pod VM, it's called. And this is the Cloud API Adapter project. And so we can see here the Cloud API Adapter is a bit of a component that manages the life cycle of those CVMs. We don't have this performance tech, but we also don't share images on the host. We have a slower startup time that might work for some workloads and be a problem for others. And we see like how this works in practice. So we create this virtual pod on the node. A CVM is started, and then the Kata runtime is, instead of talking directly to the Kata agent locally, it talks to a forwarder and starts a sandbox on the CVM. So this is like you get pretty much the performance of a local CVM. And as we learned before, there's remote attestation as a key concept of confidential computing that's also part of the project. And just to summarize, it means we want to verify assertions about the system state, and then depending on this, release secrets or even abort the execution if something is not as we expected. So for confidential containers, this means like the pod is obviously deployed in a TEE, and it's also actually what we wanted. And certain underlying system parameters, like the firmware version of the PSP, are what we want it to be. And there's like a specification that is surprisingly readable. It's called RATS. It's an RFC, Remote Attestation. It has a lot of charts. and hints how you can implement it. And if we look at this chart, we see like there's an attester that gathers the evidence, and in the confidential computing case, the evidence is TPM quotes, attestation reports from the PSB, quotes, TD quote, I think is the one from TDX. And it provides measurements of the launch configuration and the whole computing base. And the TCB pretty much means like all we need to run in all the components that we need to run a container. So the kata agent, for example, that we've seen earlier. And then there's guest components, so components that need to be on the guest, and this is specifically the attestation agent. It's a client that is an extension to kata agent, and it's doing exactly this. Like it gathers this evidence, it's an abstraction over different architectures, which makes it easier to run. So you don't have to specialize on your individual, IBM or AMD implementation. And it facilitates the remote attestation process. And the attestation service is one component that actually verifies this, again, in a kind of abstract fashion. It looks at the evidence and says, like, what is actually claimed in this evidence. Certain chain of signatures are verified, and also the reference values. So are those values within a threshold that we accept, or do they actually match the workload that we deployed? And this is enforced via policies, via REGO policies that I think data lock or close to data lock, you can describe your expectations. And finally, there's the KBS, it's like the key broker service, which is the one component that is responsible for releasing keys, like decryption keys, keys you use at runtime, to the process, to the container in the CVM, in the enclave. And depending on how successful the verification of the evidence was, we release or deny certain secrets. So there's different models. There's a background check model that is rendered here that KBS at the moment implements. And there's a different part that's called passport model. There's a lot of opinions around this. I think it's not a crucial difference. It pretty much just means, do you always go through the relying party, or do you provide the attester, so the CVM process, do you provide it with a token to retrieve secrets on its own instead of verification in the background? And this attestation agent pretty much talks to this KBS, and it has certain secrets that it requires, like the decryption of container layers, secure key release during the runtime of a pod, and also some questionable secrets that are not actually secrets that might be removed in the future, like authentication to the registry, for example. And this would be the protocol that we see here. So it's like a challenge-based protocol. So the attester goes to the KBS, and to protect against replay attacks, there's a nonce going back that will eventually end up in the evidence, so in the SNP report, for example. And once it's attested, in this case it's like a cookie session, then the attestation agent is able to retrieve secrets from the KBS. So, if you have time, do we have time?
You have 5 minutes. You can take questions if there are any, or you want to do demo there. Other questions?
Let's take questions.
You prefer questions? Yes.
Go back a couple of slides. There's a picture of the Kata container runtime, where there is the guest kernel and there's the Kata agent.
This one?
Yes, and my question is, are those components essentially provided by the user who wishes to use the confidential container, or are they provided by the vendor?
No, this is pretty much your software that you deploy in a confidential VM. So this is usually,
So as a user, I also have to make sure to bundle an agent as well as the guest kernel.
You can take one that's the ones that are provided pretty much, because those are bundles that are measured and generic. Yeah, so it's pretty much an initRD. So Kata agent in the simplest model is the initRD, and you have a kernel, and those are bundled together.
Thanks. That was unclear to me.
Yeah.
Other questions? We have 4 minutes in the schedule. Other questions?
Okay, when there's no question, then I would use the time if it's possible.
Can we get back the screen, please? We were already kicked out. Can we get the, thank you very much. Yeah, you have 4 minutes.
Yeah, that works. If we get the screen. No screen? I think we lost the screen.
Danger of live demos. Oh, there we go.
There we go. Okay. So what we get is like the software, everything is deployed. We have a KBS deployed. And our, let's see. So the only thing that we really change from a normal workload is we add the runtime class to Kubernetes. That is called Kata Remote in this case. And this demo deploys an encrypted image. We can look at the image here and see that there's annotations in the image layers, so in the OCI image layers. And if we look at those, then we see it's annotated with a secret that is stored in the KBS that the attestation agent tries to retrieve. So it's creating, but eventually what we want to see is, now it's running, is in the KBS deployment, we see this kind of challenge that we've seen on the last slide. There's the attestation process, and below we see it retrieve the secret to decrypt the layer. And it depended on the evidence that we provided from the TE. So I think the only policy here is that it needs to be in an encrypted enclave, but this was sufficient for us to allow the container to be started. I think that's the demo.
I think we are out of time. Are there any questions, very quick ones? Then let's thank the speaker. Thank you.